Welcome, everyone. Thank you for joining us once again for our monthly look at Minnesota's night skies. I'm Amber, the Public Science Events Manager at the Bell Museum. And while we've had to temporarily close our museum doors to visitors, we are happy to continue with this virtual programming. We are truly glad that you could join us this afternoon for a peek into what we can find in the evening skies throughout the month of December. Hopefully, you'll gain some tools today and some ideas for successful stargazing so you can grab your hat and gloves and spend some time outside this winter. And as always, your guide for today's observations is Thaddeus, the Bell Museum's planetarium educator. If you have any questions for him today, please enter them into the comment box on Facebook. We will indeed save some time to answer them live today. Thank you once again for joining us. Thaddeus, we're ready to hear all about what's happening in the night skies in December.
Awesome. All right. Hi. Hopefully again. Hi, everyone. As Amber was saying, we got some great stuff in our skies. And of course, you're going to want to make sure you dress very warmly. You might have been able to get away with not too much the last month or two, but now we are definitely into the cold season. So dress warmly and let's take a look at what's up in our sky. All right. So we are looking here at our sky on December 1st at about 6 p.m. Now, I am using the program that I've used before. It's called Stellarium, Stellarium. We had some great questions about it last month. Stellarium is a free astronomy program. It's kind of like almost a planetarium software. You can use it to view the sky from anywhere in the world, basically any time in the world, looking into the past, now, and into the future, as we'll be doing today. You can set it up, we are set up here in the Twin Cities. Down at the bottom, we can see Minneapolis, here 260 meters above sea level. And I've got our date and time up, and I'll have that date and time up throughout. So if you're ever not sure exactly when we're looking, just keep an eye on the bottom there for that little indicator. And we're here at 6. This is when our star map, if you download our star map from our website, that's when it's set up for here in December around 6 o'clock. And that's when, especially this time of year, it's going to be dark by 6 and especially dark as we go later into the night. But here at 6 o'clock, throughout the month of December, there's 3 really bright things to see to the south. Things that we've been seeing all throughout the summer and the fall that still remain with us. 2 of them in particular are going to be very important here into the end of the month. But looking into the sky here, we have our 3 planets. Mars over to our southeast, and Jupiter and Saturn low to the southwest. Now, these 3 will be, as we look at the sky here, decently close together. So if you're just looking vaguely to the south, if you're just looking for bright lights, look for Jupiter and Saturn, 2 bright lights very close together. And that'll be Jupiter and Saturn, and then track over to the left, to the east, and look for Mars there. Mars, of course, will be very distinctive. You might actually find Mars first. That nice red-orange color really stands out in the sky. Again, we've been seeing it all summer, throughout the fall. Now we're here on December 1st, but I'm actually going to jump way forward in time because I'm going to do it by days, actually. Keep your eyes on Saturn and Jupiter. Now, as we go later in the month, and actually, I'm going to move a little bit to the southeast so we can make sure we see, or southwest, so we can make sure we see Saturn and Jupiter. As we go forward in the month, we're getting something that hasn't happened in hundreds of years. We're getting the closest conjunction of Jupiter and Saturn since the 1600s. So looking on the night of December 21st, here about 6 o'clock, Jupiter and Saturn will appear like one little point of light in the sky, one very, very bright point of light. Now I should say conjunctions aren't rare. They're quite as rare as I might have just made them out. We actually did have a very close conjunction back in 2000. But again, this is the closest conjunction since the 1600s. So if you are looking with your own eyes, the unaided eye, it'll be like one bright point of light. But if you grab a pair of binoculars or a telescope, this is a chance to see both Saturn and Jupiter at once in the same time, magnified there in the night sky. We can see as we've zoomed in here, Jupiter with its nice cloud bands just faintly visible, but especially those 4 Galilean moons, Callisto, Io, Ganymede, and Europa here in order. as we see them here, although Io is the closest and Callisto is the furthest away from Jupiter out of these 4 moons. And a little bit over here, we do see Saturn and its little ring system. Now, if you're looking with binoculars, those rings won't appear quite like that. I've gotten a chance to look at Saturn binoculars before. Pretty basic pair, 9 by 40s, 9 by 60s. And Saturn looks more like a bright oval there, but it does look very nicely different from any other object you see. So that oval shape, that oval brightness is its rings. And we can see a few of its moons, a little bit more than you might see again. But ones like Titan do stand out very easily, the 2nd largest moon in the solar system. You can see here in this view of Stellarium, Titan is also sort of reddish orange. It's actually one of the only moons in the solar system with an atmosphere. So it has this very thick carbon dioxide and methane-rich atmosphere. And that absorbs blue light and it reflects this orange-red light back to us. Now, as we're looking here in the sky, so that's on December 21st. It's going to be very cool. Again, it's going to be very cool to watch throughout the month. And again, if we jump back, I'll just jump all the way back to the 1st. Looking here again, I'll track forward one more time here. Again, just looking day by day, always just still here at 6 o'clock, day by day, you can see Jupiter and Saturn getting closer and closer and closer to each other. So if you go out and every night and you just draw what you see there. Bring a sketch pad or just a piece of lined notepad paper, and a pencil. Draw if you've got trees and houses there. Draw them as reference points, and then mark out where you see Saturn and Jupiter above them, and go out every night and do that, and you'll see them getting closer and closer together. You can see also as well as we've gone forward to the 16th here, we've got our moon coming around. So this is also going to be really helpful in a way. The moon is going to be a good way to keep track of where stuff is in the sky because you can use it as a reference point. So here in the few days before the conjunction, the moon will be getting bigger and brighter. It'll be waxing, and it'll be moving further and further to the west. Now, as we saw there, Titan has that really nice, bright orange-red atmosphere, and that is why it is reddish orange. Don't get confused, though, in the case of Mars, there in the constellation of Pisces, the fishes, all the constellations show up. Mars is not red because of its atmosphere. It only has a very thin atmosphere of mostly carbon dioxide. Instead, the red planet we see here is covered in iron oxide, rusty dust. So this planet has been rusting for billions of years, and we can see that evidence all across the surface and in that light reflected back to us. We can also see the darker rock. So that darker area is the dark, more basaltic rock underlying that's underneath the dust. And Mars is constantly changing as we look at it. So if you are a really experienced observer, if you have a telescope, if you do astrophotography, then you can actually catch Mars changing its view every night, and especially as we go through the years. Now, this is the sky we're looking December. Got a shout out, though, to 2021 and February. Because in mid-February 2021, the Perseverance rover is due to land on Mars. So keep your eyes and ears out for that, coming up early in 2021. All right, it is currently on its way to Mars right now, getting closer and closer by the second. Now we can also see here in Stellarium, it's marked out something you wouldn't see with your naked eye, but over to the east, the left of Mars, we do have Uranus. Now Uranus here, you, again, won't see with your unaided eye. Good pair of binoculars might show it as a bright point of light, so you're able to see that there is something there. It may not be easy to identify. I've had the best of luck looking at Uranus with a telescope, and that shows a little blue disk there, very faint blue. In this case, again, an atmosphere giving us different colors. Blue light reflected back to us here on the Earth. We also see some moons there marked out. I haven't personally had good luck seeing the moons of Uranus. If you get out there and look for it, let me know if you can see that. I know astrophotographers are great at seeing that. I'm not sure any of us amateurs have ever seen the rings of Uranus, though. These are best seen with something like the Hubble Space Telescope. So if you do get some time on the Hubble, take a look at Uranus. Also, please let me know, because I think we'd be very good friends. All right, now, as we've seen popping up here a few times, I'm gonna go a few days in the past here to just the 15th, middle of the month. As we've seen popping up a few times, we do have a lot of constellations across the sky. In fact, Uranus and Mars are right near the relatively small constellation of Aries, or the Ram. We can see it as sort of one bright star, star Hamal. So if you're trying to track down Uranus especially, you can look for Hamal there and you can come down from it. Looking back over to Saturn and Jupiter, these are near the constellation of Capricorn, or Capricornus. Now Capricorn here is the Myrgoat, one of the odder constellations that I've ever seen in the sky. But it is part of a sort of a set of constellations. The Sea Goat here, the Myrgoat, is part of the constellations that make up the area of the sky known as the Sea. I'll see if I can get these in the sky here. So looking here, let's get some labels up so I don't have to remember all of these. Oh, well, Pegasus is not one of these, but ones like Pisces, the fishes, Cetus, the sea monster, Pisces Australis, the southern fish, and Aquarius. These are all constellations in this part of the sky, again, that we call the Sea. These are water-related constellations, and they were put together thousands of years ago. In this case, most of these date back to the Babylonians and the Sumerians. And overall, this part of the sky is away from the main part of our Milky Way galaxy. So these stars are very, very faint. They tend to be pretty hard to pick out. If you go out, though, when we have a new moon, that is when the moon is really not visible, when the moon is nearby the sun and isn't visible, when we get a darker sky, that can help to pick out some of these constellations. And in fact, if you check out our Constellation Hunter video series, we've talked about how to find Aquarius and Pisces, and you can go out and that'll give you a hand on finding them yourself. Now, and again, Pegasus, it's just left up here. Pegasus is not one of the sea constellations, but it is a pretty fun constellation. Actually, since it's up, I'm going to use it to point out one of my favorite constellations, or one of my favorite objects in the sky. If you have binoculars or a telescope and you can find Pegasus here, there's a pretty distinctive grouping called the fall square, because it's a square and we see it during the fall. Pretty simple. But if you follow this is sort of the head of Pegasus down, you find the star at the end called Enif. Might be mispronouncing that one, but Enif is a very bright star, very distinctive in the sky. And coming off of Enif, we can find right over here an object known as M15. M15 is a beautiful globular cluster. It's a very dense packing of collection of stars packed very close together within a few tens of thousands of light years, making up containing tens of thousands of stars. And globular clusters like M15 are orbiting around our Milky Way galaxy. So outside of the main disk of the galaxy and orbiting around it. They are some of the oldest objects we can see. Globulars like this are 12, 13 billion years old. That's billion with a B. And M13 also has a very bright central grouping and sort of an outer ring of stars. So you might be able to pick out some of that structure yourself if you're looking with a telescope, probably, to really pick out that fine detail. But it's a very easy object to see. It's a fairly bright one and really just fantastic to look at. So I highly recommend going out and looking for that. And December 15th, and again, it's very easy to find off of Pegasus. And December 15th is just a day past the new moon. So this is a great time, again, around the new moon, this is a great time to go out stargazing. You only have to deal with the light pollution of the Twin Cities. Now, as we look here, again, the new moon, which gives us very dark skies, that is also really helpful when we look this time of year for a very beautiful and bright meteor shower. Every December, right in mid-December, we have the Geminids meteor shower. Now, the Geminids gets its name, like all meteor showers, it gets its name because the meteors that appear in the sky all appear to come back from or originate from the constellation of Gemini. Now, to see Gemini, you're going to have to stay up a little bit later in the night. If you go around here, we're looking just around midnight here, middle of the month. We can see a marker for the Geminids, which you probably won't see in the sky. But we can also see the bright stars Pollux and Castor. And they make up, these are the two brightest stars of Gemini, or the twins. Now, if you're looking for the Geminids, you actually don't want to look right at Gemini. This is where the meteors appear to come from, but that means you want to look away from it. So the meteors will streak across the sky, shooting stars, and you could track them back that way, but you actually probably want to put your back to Gemini. If you're going outside, if you have a lawn chair, you're dressing really warmly here at midnight in the middle of December, look up and maybe put your head towards Gemini, put your head towards the southeast, and then you're going to want to look towards the southwestish, wherever that is on my little map here. There's southwest down there. And that'll give you a great chance to see those meteors flying above your head, the bits of rock burning up in the atmosphere. And the Geminids are one of the most prolific meteor showers we have. We get on average about 100 meteors per hour, we call the zenith hourly rate. And these meteors are moving pretty slowly. They're moving at about 17 miles per second. Okay, that sounds pretty fast, but other meteors that we get, other meteor showers like the Leonids meteor showers, those meteors end up moving twice as fast, moving up to 30, 40 miles per second, which means they just last a brief fraction of a second in the sky. Geminids meteor showers can last up to a couple seconds even, appearing very bright, giving us some very nice bolides. Fantastic meteor shower, one of the best. You really, if you're doing nothing else this year, go out and look for it. And again, it's really great this year because we have the new moon. Without the light of the moon, it's just that much easier to see. Now, also as we're looking here, we can see some other meteor showers marked out. These are the origin points for these different meteor showers, like the Cancerids, the Hydrids, the Monosaurids, and the Orionids. These are all lesser meteor showers, but they are among the many that we get throughout the year. So every meteor you see might not be from the Geminids, but if you go out under dark skies, even under city skies even, you have a good chance of seeing some nice meteors this year. All of these are named after the constellation they appear to come from. So for example, the Cancerids are near the constellation of Cancer, the crab. The Hydrids are near Hydra, the sea serpent. The Monosaurids are near one of my favorite constellations, Monosaurus, the unicorn. And of course, the Orionids are near the constellation of Orion. Orion here, let's leave him up. One of the best known constellations in the entire sky, so easy to find. You know, we're looking here to the south, here at midnight on the 16th, but if you go out sort of any time throughout December, from early evening, from 8 o'clock onwards throughout the early morning, you'll be able to spot Orion. His three bright stars that make up his belt, the stars at his shoulder, Betelgeuse over here, Bellatrix over here, Rigel and Saiph that form his feet. So easy to see. Now the main body here almost looks more like a bow tie if you're seeing it, if you sort of tilt your head to the right there. But you can also pick out the arm, which is a shield or a bow and arrow, and his club or his sword rising up above him. And Orion contains just an amazing deep sky object. You know, Pegasus back there had M15. Orion here, if you look for his belt and you come right down below it, we have M42, or the Great Orion Nebula. M42 here is a magnificent, bright, beautiful star-forming region. This is where new stars are being born. And it's pretty close to us. It's only a couple thousand light years away, which means all the stars in this nebula putting out light, heating up the gas and dust around them. They put out a ton of light for us to see right here on the Earth. So in fact, if you're under dark skies, you don't need binoculars or a telescope to see M42, the Orion Nebula. You just need your own eyes and dark skies. Binoculars do really help though. Again, basic binoculars, your 9x40s, 9x50s, they'll be able to pick out this fuzzy patch in the sky, and it is a beautiful sight. And if you can get your hands on a telescope, go for it. M42 is one of the top sights to see in the entire sky. In really this entire, and we're looking here, this is an image most likely from the Hubble Space Telescope. So again, not quite what we'd see. But this entire area of the sky where Orion is has a ton of deep sky objects. In fact, as we zoom out a little bit here, Stellarium has labeled some of them for us. There was one named Casper the Friendly Ghost Nebula. I haven't heard of that one before. It's also known as M58. I have heard of that. But we can see down near Alnitek here, we can see another Another area of stellar formation. We can see, in fact, one of the most famous areas. If you really tilt your head, if you're looking at this on your screen, you might tilt your head to the right or turn your screen. But over here, we have the Horsehead Nebula. So this area, and we can see other gas and dust here, this area has a lot of deep sky objects, things to look at, because it is very close to our Milky Way galaxy. So we can see the Milky Way arching up and down through the sky here. And really, wherever we look at the Milky Way, there's a lot to see. Now, if we come up above Orion here, we can also spot the star Aldebaran, which is the Eye of Taurus, or the Bull, one of Orion's enemies here in the night sky. And in fact, coming right off the back of the Bull, we can find the Pleiades, or M45. Now, M45 here, the Pleiades, is one of the most famous deep sky objects out of really any of them. One that's been known, the Seven Sisters is another name for it, or Subaru in Japan, and lends its collection of stars here lends itself to the Subaru car logo. It is so easy to see. Again, you don't need binoculars or a telescope. You can see with your own eyes. If you do want to see it closer, in fact, all I suggest are binoculars at most, because this is an open cluster of stars. It's a group of about 1,000 stars that are spread out across several hundred light years. So you don't want to magnify it too much. If you do that, you'll just focus on individual stars, and it won't look like too much. So instead, you get that wide field of view that binoculars provide. You can see this collection, this family of stars. This is actually really the second stage of a star's life. It's what happens after stars are born inside a nebula like the Orion Nebula. We get a bunch of stars born at once, dozens or hundreds, and they stick together because of their mutual gravity. And then they start orbiting around the galaxy. Over enough time, they do spread out. The stars, their gravity, they interact with each other and they get flung outwards. And so open clusters do eventually spread out, and they become sort of single stars all on their own. Or in many cases, they become binary stars. So you get two stars orbiting around each other that were once born in a nebula, like the Orion Nebula, traveled in a cluster like the Pleiades, and now are just on their own throughout the galaxy. But that dispersal won't happen for quite a while. With the Pleiades, these stars are pretty young. They're only about 65, 70 million years old. So they've got easily 100 million years before we really start to see this dispersal effect. And we'll probably still see them pretty close together for a good 100 million years after that. So stick around and keep an eye out for that. Now, if you are sticking around, if you are keeping an eye out for those things that do take quite a while, I also suggest looking for something traveling up and down traveling up in our sky here, but part of our solar system. All throughout November and now into December, we will hopefully be able to keep an eye on a comet known as M3. Well, C2020 M3 Atlas, but M3 is shorter and easier to say. M3 right now, well, actually, you know what, I'm going to jump back to now. Today we are recording this on the 23rd of November, and we can see that M3 is marked out down here. It's actually near Taurus. No, I've lost M3. As we go forward into December, though, and we see the moon orbiting past us there, M3 will be moving up in the sky. We're looking here to the southeast, by the way, at around midnight again, but it is visible early in the evening too. We can see it as we go through December here, moving higher and higher in the sky, moving past, by the end of December, moving past the bright star Capella and onwards and upwards. So M3, again, is visible. This comet is hopefully going to be visible throughout December. I say hopefully. Comets are very fickle objects in the sky. They do brighten and dim on their own time. So by the end of December, it might have just disappeared entirely. But you know, if that happens, send me an email. I'll probably also already know about it. Hopefully, though, it does remain visible, especially because again, this last, as we look forward from about the end of the first week of December, from the 7th to about the 21st, we'll be going through that either waning moon phase or the new moon phase. So we'll get these very dark skies. Something that's really going to help with finding what is still a faint object in the sky. You will need binoculars to see this comet, maybe a telescope. It really does dim a lot. but it's going to be very easy to track down. We've got bright stars here, Elnath here that makes up the Horn of Taurus and part of Auriga. Auriga, excuse me, is the charioteer. It always looks more like a blob to me, but no one ever asked me about it. And then again, M3 is moving up past the star Capella up here. So it's going to be easy to spot when it's in this part of the sky. All right. So I think, keep an eye on our time here. I'm going to take a little bit of a detour here just to throw out one quick thing that's also happening on December 21st. I know, of course, this time of year, we don't always have clear skies. So I do hope if you get a chance, even if we don't have clear skies, I do hope you get a chance to go out or to keep an eye on the news on December 21st, because on December 21st, there is actually going to be hold on, I'm sorry, I'm jumping way ahead. On December 14th, we are going to have a total solar eclipse. Now, this total solar eclipse will not be visible here in North America, but it will be visible in South America. So even if we have clear skies up here, keep your eye on the news for December 14th for this total eclipse. It'll be visible across the southern portion of South America, and there will be different astronomy sites that are live streaming it. Groups like SLOO, S-L-O-O, will be live streaming it, hopefully along with some observatories that are situated down in South America. But what I wanted to mention, though, on regarding the sun, but up here in North America, is on December 21st, we also have our December solstice. So on December 21st, the sun will reach its lowest point in the southern sky. So it'll be as low down as it gets there in the sky. It will be the shortest day of the year. It marks out the beginning of the first day of winter here in the Northern Hemisphere. And, well, actually, as I think about it, that always kind of depresses me. The winter solstice to me isn't quite as exciting as the summer solstice. The shortest day of the year, we get the most night. Well, actually, hold on a second. We get the most nighttime. The great thing about December solstice and all these months is we get these long hours of darkness, even though it is going to be very cold, even though you have to wear a lot of clothes, even though, yes, we get clouds here in Minnesota, we have long, long hours of darkness. So you can get out from the early evening, from 6 o'clock until the early morning, until 6 a.m. And you can see all sorts of beautiful sights across the night sky. Now, the December solstice is going to be marked by festivals across the Northern Hemisphere, as it has been done for tens of thousands of years. And I hope you get a chance to partake in some of those celebrations as we celebrate the first day of winter, the longest day of the year, and all the cool things we can see up in the night sky. All right, Amber, I'm going to turn it back to you here. I know we've got just a couple minutes left. Anything you'd like to ask?
Yeah, so much for taking us on that journey, Chad. We did have a question that came from Lacey, and I think we get this question quite often, but she's wondering if you have any recommendations for the best apps to download for stargazing.
Yeah, it depends a lot on whether you have an iPhone or an iPad, iPhone or Android. I guess an iPad is another Apple device. I have an Android. I like apps like Star Chart or Stellarium, what we're using right here. These are both the apps. This has an app version. If you have an iPhone, an Apple device, which I don't personally have, I have heard great things about Sky Safari. You can also, whatever app store you're looking at, if you search something like Sky Chart or Star Chart, you'll find a bunch of different apps. And they work in slightly different ways, but they all tend to work basically the same way at heart. These are ones on your phone where you can hold your phone up, and it'll show you what you're looking at in the sky, more or less. It depends a lot on your phone too. But again, Star Chart for Android, Stellarium for Android, and I've heard good things about Sky Safari for Apple iOS.
Okay, thank you for sharing that. Yeah. I also had one question for you about some of the images that we were seeing around the constellation of Orion, which of course is super, super visible and easy to see this time of year. And one of the things that, as you were taking us on a tour of that, I noticed like some of the most prominent images that we have from, from Hubble are all taken in this area. You've got the Horsehead Nebula, you've got the Orion Nebula, and a lot of us, these images are really synonymous with what we know about space. Can you tell us a little bit more about what's going on inside these nebulas? I mean, I know we know that there's star formation, but is there any way you can tell us a little bit more?
Sure. I'll zoom back into. Well, I like the Orion Nebula, but I'll try to do both because the Horsehead Nebula is really amazing. So there's so much to say. When we look at space, it does appear, when we just look at the space in between stars, it does appear very dark. But space, our galaxy, the universe, it's filled with a ton of dust. Now, this is dust actually a lot like we find just sort of around us here on Earth, dust kind of like you find under your bed. But there's other things too. There's things like ices, frozen things, frozen oxygen, frozen ammonia. There's rocks like silicate type rocks. There's all sorts of different materials. And in areas like nebulas, these areas here, these are areas where this gas and this dust, it's collected together. And this can be caused by many different reasons. Everything's sort of moving around the galaxy. So you just get areas where dust starts clumping up because it's very cold and it starts sticking together. It can also start clumping up because we get a large supernova. When a supernova happens, when a star explodes, the energy, the shock wave from that star out through space, that can actually cause gas to get compressed together. So in any case, we get gas and dust that starts clumping together. Now, as that starts clumping together, atoms, especially hydrogen atoms, they can get stuck together. And as more and more material builds up, stick with just hydrogen, as more and more hydrogen builds up, as it sticks together, it gets to be so massive, there's so much of it there, that its own gravitational pull actually causes it to collapse down in on itself. And the hydrogen atoms, these tiny little things that make up a lot of everything else, these atoms get stuck together, they start fusing together. And this hydrogen fusion actually releases energy. And they stick together and they start forming new elements, but they start releasing energy, light. So this is actually how stars are born. These gases and dust get stuck together, hydrogen in particular. Hydrogen starts fusing together and light starts being released, and there you go. You have a new star. I mean, there's quite a bit more to it than that, I should say. But this is what's happening in these nebulas because we have this concentration of gas and dust. And we can actually see here the very bright core. We'll zoom in a bit more. And in particular, in the Orion Nebula, there's a bright cluster of stars called the Trapezium Cluster. They're some of the youngest stars we can actually see in our galaxy. They're estimated to be less than 10,000 years old. They're very bright, and they tend to overwhelm a lot of photographs. So we can see that bright core here, which is really just overwhelmed by a couple stars very close together. But we can still see even actually the light that these stars are putting out, they're pushing gas and dust outwards, just like a supernova can push gas and dust around. So we can actually see these outer edges here, it's actually a rather large cavity that's formed in the nebula where gas and dust has been pushed out because the stars have actually formed inside the nebula. So we're looking here at this multi-million year long process of stuff being born and then stuff eventually over enough time dying as well, or just being spread out. These areas are bright, and we get the beautiful different colors we see because they are made of a lot of different materials. So things like oxygen or sulfur, these will glow different colors when the atom is hit by a bit of energy, by a bit of light, and it puts off its own light. This is actually why we have the different colored lights of the aurora borealis. That's atoms in our atmosphere that are glowing from sunlight. One final thing I'll say, because I will go back to our Horsehead Nebula here. We also find in a lot of nebulas like this, and we can see up here as well, in a nebula whose name I'm forgetting, we can see these long dark areas. Now, these are actually areas, again, just like the space in between stars. It's not actually empty. This is where we find a lot more gas and dust. In fact, so much gas and dust that it's absorbing visible light. So we can't see anything there with our eyes, just because there's a lot of very cold gas and dust in the way. And this is what Hubble sees. Hubble sees basically in the visible part of the spectrum. Other telescopes, though, like the Spitzer Space Telescope or Chandra, these telescopes are able to see in the infrared or an X-ray. They're able to see outside the visible part of the spectrum that we see. And in fact, even these dark areas are glowing very brightly in infrared, and it's where we find a lot more stars. Again, this is a cold area where gas and dust is clumping together. So this is actually, these dark areas are some of the most active areas in these entire nebulas. All right, did that help answer? That was a lot more detail. And there's so much more to study about these as well. In fact, sorry, I am going to stop talking after this. We do find at the center of M42, or there is suspected to be, last time I checked, there is suspected to be a small black hole at the center of Messier 42, the Orion Nebula. It's suspected to be there because we can watch stars moving around, and the motion of those stars seems to suggest an invisible mass, a dark mass, a black hole. However, I am recalling a study from several years ago, so it's very possible that we've done some more studies, some more follow-up on that, and maybe it's something else there. Maybe there's a neutron star there, something else we can't very easily see. It'll be something to look up. All right.
Thank you so much, Tad. I really appreciate that. That's why I ask these questions of you, because I don't have the background or knowledge to understand it. So I appreciate your interpretation and helping us to understand that quite a bit more.
Yeah, you're welcome.
And also thank you very much. I know we're at the end of our time, but thank you for taking us on an exploration for the month of December. I do want to let our audience know that if you are interested in learning more, we would definitely encourage you to check out the Bell Museum's website. You can find out lots of information there about the Constellation Hunters program, and there are activities and even lessons to explore for children of all ages. We do also hope that you'll join us for our next monthly program. The Minnesota Night Skies program for the month of what we can see in January will happen on Monday, December 21st at 4:00 p.m. So we hope you'll join us again then. Thank you very much for being here today. We hope you all have a wonderful evening.
All right. Stay safe, everyone, and stay warm.